Slope of PV graph. PV graph are very handy tool to represent any thermodynamical process. We have majorly, we have these four process: isobaric, isochoric, isothermal, and adiabatic process. Other than that, there are also some other process, but today I am interested in all these four only because they are most common one. So uh, these are isobaric, it is a parallel line along volume axis, and similarly for other I haven't drawn for isothermal and adiabatic yet. So actually we are interested in the slopes of these PV graph. So for isobaric process we know there's no slope, zero it is. For isochoric it is infinite because it is perpendicular upon base. For isobaric there is no perpendicular. For isochoric there is no base. But for isothermal you can see it follows Boyle's law, and this PV equal to constant. So now we will differentiate this. In order to find slope we require to differentiate it. Now there are two variables, P and V. We can't say that P is constant or V is constant, both are variables. So in such a cases when there are two variables and we have to differentiate, there is a formula in calculus for two variables. Here it is. So if x and y and z are two variables, then this is how they will split. So on the basis of that I have done that, and dc by dv is 0. So from here if we do some rearrangement, so this dp by dv, which is slope, actually it comes out to be minus pv. So what is interesting about this negative sign, that is why this it has negative slope, it is coming downward. And we know that inverse proportion graph are have this shape. So now let's move to this adiabatic process. So adiabatic process follows Poisson's law, and here we have Poisson's equation PV to the power gamma, that is gamma. What is that? Gamma is Cp by Cv, that is specific heat capacity of gas at constant pressure by constant volume. So it has different value for different types of gases on the basis of their atomicity. I have covered it in a different video. So here you can see, in order we are interested in its slope, so that is why I am differentiating this second one again. And the same formula of that two variable formula for to differentiate two variable function, I mean two different variables. So this is how it will split. It will turn out to be P gamma v to the power gamma minus 1 dp by dv v to the power gamma equal to 0. Of course we know that is 0. Now if we divide entire equation by v to the power gamma minus 1, so a little bit algebra if you will do, you will get this dp by dv equal to minus gamma. Okay, so we can see that slope of PV graph for isothermal process is gamma times that of adiabatic process. So it means graph for adiabatic will also look like that of isothermal process, but it should be much steeper. So here I am going to draw it. So see, this is not for adiabatic, this is for isothermal. I have taken it as a reference. So I have to make for adiabatic, I have to show much sudden change here. So that is why it is much steeper than that of isothermal. So that's all in this video. Bye.